Picture a 300-foot steel crane bolted to the top of a finished skyscraper, sitting over a city full of people, cars, and buses. Now somebody has to take it apart, in mid-air, with no room for mistakes. Drop one bolt from that height, and it hits the ground like a bullet. Lose control of one section, and you've got a catastrophe. This is one of the most dangerous, most technical, most jaw-dropping operations in all of construction, and most people have no idea it's even happening above their heads. Let's fix that right now. Today we're breaking down the 4 main techniques crews use to bring tower cranes back down to earth, and why each one is basically a different kind of engineering superpower. Buckle up. Before we talk about getting the crane down, let's spend 60 seconds understanding what these things actually are. Because this isn't just a big metal arm, this is a seriously complex machine. Tower cranes are the giants you see on skyscraper construction sites. They can stand taller than 265 feet. Their long horizontal arms, called jibs, can stretch out over 200 feet in both directions. And they can lift loads of up to 20 metric tons. That's like picking up 14 cars at once. A tower crane is always built in 3 distinct phases. A concrete foundation is prepared so that the crane is safely anchored to the ground. Then a mobile crane assembles the tower crane by lifting several segments of tower into place. And finally, the core components are attached. As the building goes up, the crane goes up with it. It literally climbs. These specialized cranes are designed with telescoping sections that allow them to grow in height as the building rises. As the building progresses upwards, the crane climbs along with it. Hydraulic mechanisms within the crane extend the mast upwards, lifting the crane to the desired height. So, by the time the building is done, the crane could be hundreds of feet in the air, bolted to the side of the building, with a massive concrete slab anchoring it at the bottom. Now you have to get it down. Good luck, right? Well, here's the thing. Engineers have figured out not just one way to do this, they've figured out 4, and they're all totally different. Let's go through each one. This is the technique that makes people do a double take the first time they hear it. You want to know how you take down a giant crane that's stuck on top of a skyscraper? You build another crane to take it down. Yes. You use a crane to remove the crane. It's like calling a tow truck to tow the tow truck. Here's how it works. When the big tower crane has done its job and the building is complete, workers haul a much smaller crane called a derrick all the way up to the roof. Tower cranes construct derricks on the rooftop of the finished project. These derricks then help dismantle the tower cranes, and in the case of internal climbers, lower their parts one by one to the ground using extremely long cables. So, the big crane actually hoists the baby crane up first. The baby crane gets bolted to the roof, and then the baby crane starts taking the big crane apart, piece by piece. This process begins with the removal of the crane's load and counter jib, followed by the disassembly of the jib and the slewing unit. Each section is methodically detached and lowered, typically using auxiliary cranes or heavy lifting equipment. The mass sections are then disassembled in the reverse order of their erection. Each piece gets lowered down on cables, hundreds of feet of cable, slowly, carefully, touching down on the street below like a giant metal egg being set down by a robot. Carrying out this process begins with the large mobile crane holding the weight of a part of the tower crane, while workers disconnect that part from the tower crane structure. Then the mobile crane lowers the disconnected part to the street. Once the big crane is fully disassembled, the derrick gets taken apart too, and since it's small enough, workers can usually handle that part by hand, or with a mobile crane on the ground. Boom! Problem solved, except it takes days, or even weeks. Delays were due to wind velocities greater than 25 miles per hour at the top of the tower crane. In such high winds, the potential for parts of the crane to swing around is too great, and neither erecting nor dismantling a tower crane can be done safely. More on that wind problem later. It's a big deal. This one is clever in a totally different way. Imagine a family of cranes. The grandfather crane builds the skyscraper, but when it's time to go, instead of calling the derrick, the grandfather crane actually builds a sun crane, which is a slightly smaller version of itself, right there on top of the building. That sun crane then dismantles the grandfather, Then a grandson crane dismantles the son, and so on, each generation getting smaller, until eventually you've got a crane small enough to be taken apart by a regular mobile crane on the ground. This is called generational assembly, or sometimes the crane-on-crane disassembly method, and it's used on some of the most complex skyscraper projects in the world. Cranes are assembled atop skyscrapers using methods such as the external climbing method, where the crane expands upward along the building's exterior, or the internal climbing method, where the crane ascends from within the building. With generational assembly, it goes in reverse. Each new, smaller crane is assembled from components that the previous crane lifted up. The parts get reused, the cranes get smaller and smaller, and eventually the building is fully clean. It's expensive. It takes expert planning. You need to know months in advance exactly how many generations of cranes you'll need, based on the height and weight of everything involved. But for the tallest skyscrapers, the ones pushing 1,000 feet and above, it's sometimes the only sensible option. The erection and dismantling of tower cranes is a complex process that requires careful planning, qualified personnel, and strict adherence to safety procedures. Throughout the process, it's critical to have detailed engineered plans, conduct risk assessments, hold safety briefings, and have competent persons oversee the work. Okay, this one is the one that makes engineers look like absolute wizards. What if the crane could just lower itself? What if, instead of needing any help at all, the tower crane just collapsed in on itself like a collapsing telescope until it was short enough to be reached by a ground crane? That's exactly what self-telescoping does. Here's the magic behind it. A climbing frame or cage is assembled around the crane tower at the desired elevation. The climbing frame is a structural steel frame that surrounds the crane tower and includes integrated hydraulic jacking systems. The jacks are synchronized to lift the entire crane tower upwards in incremental stages, typically ranging from 20 to 30 feet at a time. Now, here's the twist. When you run that process in reverse, the crane doesn't go up, it goes down. The hydraulic system lowers the crane's top section. Workers slide out a mast section, which is a chunk of steel tower, and lower it to the ground. Then the crane lowers again. Another section comes out. Down it goes. Repeat. The process of erecting and dismantling tower cranes is called climbing. It refers to adding and removing sections of the mast, the central tower of the crane made up of vertical steel trusses, so the overall height is either increased or decreased. The crane is basically unbuilding itself. It's shedding pieces like a snake sheds its skin, getting shorter and shorter until it's close enough to the ground that a regular mobile crane can handle the rest. The hydraulic system is the heart of a self-erecting tower crane. It's designed to maintain precise control throughout the process, with safety mechanisms that prevent unintended movements or overloading. The beautiful thing about self-telescoping is efficiency. There's no need to haul a derrick up to the roof. There's no generational chain of cranes. The machine does the work itself. The tower or mast sections are systematically disassembled and lowered, often using a mobile crane or the crane itself in a self-dismantling process. It's like the crane was always designed to disappear when the job was done, a magic trick engineered in steel and hydraulics. For mid-height skyscrapers, say 20 to 40 stories, this is often the go-to method. It's faster, it's cost-effective, and it requires fewer external resources. The downside? You need the right kind of crane to begin with. Not all tower cranes are built with self-telescoping systems, so this has to be planned from day one of the project, before the crane even goes up. And now, the crowd favorite. Forget cables, forget derricks, forget hydraulics. What if you just flew the crane away? That's right. Sometimes, construction crews call in a heavy lift helicopter, sometimes called a sky crane, to physically pick up pieces of the tower crane and fly them down to the ground. A heavy lift helicopter flies the crane to the top of the construction site piece by piece. Just a single segment of a crane's tower can weigh between 3,000 and 20,000 pounds. For taller skyscrapers, the heavy lift helicopter is used to remove tower cranes from construction sites. It positions itself near the skyscraper and lifts the crane sections one by one, transferring them safely to the ground. The entire process requires careful coordination between the helicopter pilot and workers on the site. This is some military operation level stuff. The helicopter hovers, perfectly steady, while workers on the roof attach rigging cables to a section of the crane. The pilot holds position. The section gets unbolted. The helicopter lifts away, flies it down, sets it on the street, returns for the next piece. And it does this over and over until the crane is gone. Once the crane height is reduced to a safe range, a mobile crane or a heavy-duty helicopter can be used to dismantle the cranes segment by segment and lower them to the ground or a lower level. Now, you might be thinking, why don't they just do this every time? Why bother with derricks and telescoping and all that? Simple. Cost. Hiring a heavy lift helicopter for a full day of operations costs tens of thousands of dollars per day. And the cranes used, aircraft like the Sikorsky S-64 Sky Crane or the Mi-26, aren't exactly hanging around waiting for a call. They're specialized machines with specialized crews, so helicopter removal is usually saved for situations where other methods just won't work. Maybe the site is in a dense urban area and there's no space for a ground crane. Maybe the building is so tall that cables won't reach. Maybe time is critical and every hour of delay costs more than the helicopter. A combination lift method is used for taller skyscrapers and heavy tower cranes that exceed the lifting capacity of a single mobile crane or helicopter. In this process, sections of the crane tower, like the jib and counterweights, are detached using hydraulic cylinders. A heavy lift helicopter works on the ground or roof with a mobile or second crane. Sometimes you use a combination. Helicopters take care of the high stuff. Mobile cranes handle what's closer to the ground. Tag team engineering. Either way, watching a helicopter lift a 10-ton piece of crane through the downtown skyline is one of the most spectacular things you'll ever see on a city street. If you ever catch it live, stop everything and watch. It's worth it. All right, let's slow down for a second. Everything we've talked about sounds exciting and cool. And it is cool, but it's also incredibly dangerous. These are multi-ton steel structures being disassembled at hundreds of feet in the air, in the middle of cities full of people. So, how do crews make sure nobody gets hurt? The answer is obsessive planning, like almost unbelievably obsessive. The first step is risk assessment. When it comes to taking down a tower crane, safety isn't just important, it's everything. The process always starts with a good hard look at what could go wrong and how to stop it. Workers are strapped in tight and trained to use their safety gear. And the team is always thinking about how much each bit weighs and how it will affect the rest of the crane as it gets taken apart. Step 2. Personal protective equipment, PPE. Workers must wear appropriate personal protective equipment, such as helmets, gloves, harnesses, and safety boots. At those heights, a dropped wrench becomes a missile. A slipped foot becomes a life or death situation. Every single person on that rooftop is harnessed, helmeted, and clipped in. Step 3. Wind monitoring. This is a big one. Wind is the enemy of crane dismantling. Delays due to wind velocities greater than 25 miles per hour at the top of the tower crane are common. In such high winds, the potential for parts of the crane to swing around and back and forth is too great, and neither erecting nor dismantling a tower crane can be done safely. Work begins well before sunrise to take advantage of low winds early in the morning. That's why you will often hear about crane dismantling happening at 4 or 5 in the morning. Early morning is typically the calmest time of day. Step 4. No unauthorized people anywhere near it. Employees must not be in or under the tower, jib, or rotating portion of the crane during erecting, climbing, and dismantling operations until the crane is secured in a locked position and the competent person in charge indicates it is safe to enter this area. Streets get closed, barriers go up. Exclusion zones are established around the entire base of the building. Because a falling piece of crane, even a small bolt from 300 feet in the air, could be catastrophic. Step 5. Engineering oversight. Tower crane foundations and structural supports must be designed by the manufacturer or a registered professional engineer. Nothing happens on a crane dismantling job without sign-off from a qualified engineer. In the United States, the Occupational Safety and Health Administration, or OSHA, has a whole section of law dedicated specifically to tower crane safety. It covers everything from how the foundation is built to how the dismantling crew is supervised. Step 6. Emergency planning. Workers always have a plan B and C and D. Emergency drills are practiced. It's like a fire drill, but with bigger toys. So, Next time you're walking through a city and you see a tower crane up there on top of a half-built building, take a second. Think about what it took to get it up there, and then think about the fact that when it's done, someone is going to have to figure out how to get it back down. If this blew your mind, smash that like button and subscribe.